Hello everybody, welcome into another lesson. So today we are going to talk about function operations. So you can do the four standard operations with functions. You can add them, subtract them, multiply them, and divide them. And then we're going to talk about a fifth thing you can do with them called composition. But what we're going to do today is we're going to perform the given function operations and state the domain of the result. So here you have f of x equals x plus 3 and then g of x equals 5x. We're being asked to find f of x plus g of x. Well, all you do when you add or subtract functions or multiply or divide, you're just going to put those values in. So f of x is x plus 3, right? So you'll have x plus 3 for f of x, plus that 5x for g of x. Now you're just going to add these. You will literally get 6x plus 3 for your function result. So f of x plus g of x would be 6x plus 3. Now we're also being asked to find the domain. The domain is all values of x for which this function is defined for. So ask yourself, would there be any values of x which this is not defined for? Well, this is a standard linear function, so x is defined for all real numbers. So the domain would literally be all real numbers, or the interval from negative infinity to infinity. That would end up being your domain because there's not a single value for which this is not defined in the set of real numbers. So easy enough. Alright, let's see. We have f of x equals 3x to the 1/2. Then we have g of x equals negative 2x to the 1/2. So f of x equals 3x to the 1/2, g of x equals negative 2x to the 1/2. They also want us to find f of x plus g of x. So again, take your values for which these are. F of x is 3x to the 1/2. G of x is negative 2x to the 1/2. So you'll end up getting 3x to the 1/2 minus 2x to the 1/2, which would just give you x to the 1/2. Well, here's the thing. What is x to the 1/2? It's also the square root of x, right? So either of these two answers would work. You would get x to the 1/2 or simply the square root of x. Now, what is the domain of this function? In other words, are there any values in the real numbers for which x is not defined? Well, we know you can't take the square root of a negative number, right? Literally, you can't do that because there's no real value for the square root of a negative number. It only works from 0 to greater. So the domain is actually going to end up being 0 inclusive to infinity. Because taking the square root of a negative number is not defined in the set of real numbers. And that's all we care about is the set of real numbers. So the domain is 0 inclusive to infinity in this case. Alright. Now, f of x equals negative x to the 2/3, and then g of x equals x to the 2/3. This time we're going to find f of x minus g of x. So we have f of x equals negative x to the 2/3, g of x equals x to the 2/3. They want us to find f of x minus g of x. So what was f of x? That's negative x to the 2/3 minus the x to the 2/3. So negative x to the 2/3 minus x to the 2/3 would end up giving you negative 2x to the 2/3, which can also be rewritten as negative 2 times the cube root of x squared. Either way, you could write this either way, as negative 2x to the 2/3 or negative 2 times the cube root of x squared. Now, we have to ask ourselves what the domain is. Are there any values for which x is not defined in the real numbers? Well, the cube root is actually defined for all values x, because you can get a cube root of a negative number in the set of real numbers. So the domain in this case is actually going to end up being the entire set of real numbers, from negative infinity to infinity. That would be your domain of the new function you just got. Let's see, f of x equals x squared minus 3. G of x equals x plus 5. So f of x equals x squared minus 3. G of x equals x plus 5. They want us to once again find f of x minus g of x. So we will find f of x minus g of x. So this is going to be the quantity of x squared minus 3 minus the quantity of x plus 5, which would end up simplifying into x squared minus x minus 8. So that's the f of x minus g of x, is x squared minus x minus 8. Now, what's the domain? Are there any values for which x is not defined? Well, this is a standard quadratic equation, so x is defined for all real values. So the domain is going to be from negative infinity to infinity, because you just have a standard quadratic function at this point. Alright, let's shift it up a little bit. Alrighty, so we have f of x equals 7x to the 2/5, g of x equals negative 2x to the 3rd. This time we're being asked to find f of x times g of x. So we're going to find f of x times g of x. So this is going to be taking that 7x to the 2/5 times that negative 2x to the 3rd. Alright, so your coefficient, 7 times negative 2 is negative 14. X to the 2/5 times x to the 3rd, so that would be x to the 2/5 plus 15/5. That'd be negative 14x to the 17/5. Which also, okay, what is x to the 17/5? Well, isn't that going to be the same as, that's actually going to be the same here as, let's see, negative 14. This would actually break down into 2/5 and x to the 3rd again. So you can leave it as negative 14x to the 7/5, Or you could also leave this as, this could end up being considered negative 14x to the third times the fifth root of x squared. You can leave it in either form when you break down the exponents. This is negative 14x to the 17/5, or you can write as negative 14x to the third times the fifth root of x squared. Alright, so what is the domain of this function? Are there any values of x for which this is not defined? Well, the fifth root is an odd root, which means you can also get negative numbers and get a real number. So the domain in this case is actually the entire set of real numbers, because x would be defined for every real number. All right. F of x equals x minus 4, g of x equals 4x squared. We are once again being asked to find f of x times g of x. So we are going to take f of x times g of x. So this is going to end up being the quantity of x minus 4 times the quantity of 4x squared, which would end up being 4x to the third minus 16x squared. And that would be what you get. You'd end up getting 4x to the third minus 16x squared. Now, what's the domain of this thing? Are there any values of x for which this is not defined? Well, this is just a standard cubic equation, so x is defined for all real values of x. So the domain would end up being from negative infinity to infinity. And in this case, it's defined for all real numbers. All right, let's shift again here a little bit. F of x equals 9x to the negative first g of x equals x to the 1/4. Okay, so we have f of x equals 9x to the negative first, g of x equals x to the 1/4. This time, they want us to find f of x divided by g of x. So we are going to take f of x and divide it by g of x. So take your 9x to the negative first, divide that by your x to the 1/4. Well, clearly 1/4 is bigger than negative 1, so the x is going to favor the denominator. So 1/4 minus negative 1 would turn into 1/4 plus 1. This would end up giving you 9 over x to the 5/4, which is one way you can write this, which would be the same as 9 over x, 9 over x times the fourth root of x. See what I did there? Because this is the same as x to the 4/4 times x to the 1/4. Well, x to the 4/4 is just x to the first, then you have that extra fourth root of x. So you can write this in either format. They both mean the same thing. Now, are there any values for which x is not defined? Okay. Well, we definitely can't allow 0, right? Because that would give us a 0 in the denominator, which would be undefined. So 0's out. Now, what about the fourth root of x part of this? Well, it's an even power root, so it would be the same as taking a square root, since it's an even power root. You can't have an even power root of a negative number in the real number system. So normally we could include 0, but since it's in the denominator, we can't include 0. So we can only deal with positive numbers. So the domain of this new function is going to be from 0 non-inclusive to infinity. It would just be the entire set of positive numbers. It would be from 0 non-inclusive to positive infinity. All right. So let's see, f of x equals x squared minus 5x. G of x equals x. Okay. So we have f of x equals x squared minus 5x. G of x equals x. All right, so once again, we are going to take f of x divided by g of x. Which that's going to equal x squared minus 5x, all that divided by x. Okay. Now, what do we notice? We can factor out a common x in the numerator, right? This would be the same as x times the quantity of x minus 5 all over that x. And of course your x will cancel out between numerator and denominator. You literally would just end up with x minus 5. Alright, so you get x minus 5 for the f of x divided by g of x. Now here's where it takes an interesting turn. Since this looks like a simple linear function, it looks like the domain's all real numbers, right? It certainly does, but why is that not the case? You always have to go by the original expression, which has an x in the denominator. If you put in 0 in the denominator of a f of x divided by g of x, you have an undefined expression. So the domain is the set of all real numbers except 0. So that would be from the interval of negative infinity to 0 non-inclusive in union with 0 non-inclusive to positive infinity. So literally every real number except for 0 is a viable answer, because if you put in 0 in the original function, you'll get a 0 in the denominator. So that's why 0 won't work. But everything else will. Alright, let's move on to composition of functions. Now, we have f of x equals 6x to the negative first g of x equals 5x minus 2. They want us to find, here's how it's written, f, it looks like fog, f of g. Well, what the heck is that? If it looks like fog with like a open circle in the middle of the functions between them, that's called a composition. This is the composition of functions. And the order does matter. If you see f composition g, this literally means you're going to take f of g of x. So a composition, you take the second function to the right of the composition sign, put the entire function into the first function. So you're going to take f of g of x. Well, what does that look like? So f of x is 6x to the negative first, right? You're going to put that whole 5x minus 2 into where that x to the negative first goes. So this would be 6 times the quantity of 5x minus 2 to the negative first. Alright, well, here's the thing. What is 5x minus 2 to the negative first? That's just going to take it and put it in the denominator with a positive first power. So that would make it 6 over 5x minus 2. So that's the composition of the function of f composition g. You would get 6 over 5x minus 2. Now, what is the domain of this composition? We have to figure out any numbers that would make this function undefined. And if you have a denominator equal to 0, that's going to make the function undefined, right? So what you can do is take your denominator itself, set that equal to 0. So 5x minus 2 equals 0 will give you 5x equals 2, which would mean x equals 2/5. So in other words, x cannot equal 2/5. That's where the function will be undefined. It's defined for any other real number except x equals 2/5. So the domain is actually going to end up being from negative infinity to 2/5, non-inclusive, in union with 2/5 non-inclusive to infinity. That would be the domain of this composition function. It's just not defined at 2/5. Now let's reverse this a little bit. Let's keep our same functions, but this time we're going to take g composition f. So we're taking g composition f. It looks like Goff. Well, g composition f is literally g of f of x. So this proves that order does matter when it comes to compositions. The order does matter. So this time we're taking g of f of x. Well, g of f of x, so you're going to put the whole f of x function into where that x is in 5x minus 2. So this would be 5 times the quantity of 6x to the negative first minus 2, which would end up giving you 30x to the negative first minus 2, which could also be written as 30 divided by x minus 2. So there's your g of f of x, g composition f. You get 30 over x minus 2. Now, are there any values for which x is not defined? Well, again, you can't have your denominator equal to 0. It could be anything else but 0. So literally, the domain is going to be from negative infinity to 0 non-inclusive in union with 0 non-inclusive to infinity. So this proves that order does matter with compositions. You get completely different functions and completely different domains. All right. I have about 4 more, then we're done. All right. Alright, so we have f of x equals x squared minus 3, g of x equals x squared plus 1. Well, guess what? We're going to find f composition g. So let's find f composition g. That, of course, would be f of g of x, which means we put the entire function of g of x into the x part of f of x. So this is going to be the whole quantity of the x squared plus 1, that g of x, raised to the second power minus 3. Alright, so let's see, let's expand this out. You would end up getting x to the fourth plus 2x squared plus 1 minus 3, which would end up giving you x to the fourth plus 2x squared minus 2. So there's your f of g of x, f composition g. You get x to the fourth plus 2x squared minus 1. Now, what is the domain of this function? Well, it's just a standard fourth degree polynomial, so the domain's the entire set of real numbers. It would literally be from negative infinity to infinity. There's nothing for which this isn't defined in the real numbers. So it's the entire set of real numbers from negative infinity to infinity. Alright. And you guessed it, we're going to reverse this. This time we're going to take g composition f. So we're taking g composition f, which is the same as g of f of x. So let's see. You're going to take that entire x squared minus 3 quantity, raise that to the second power, and then add 1. Which, when you expand this out, would end up giving you x to the fourth minus 6x squared plus 9 plus 1, which would end up giving you simplified x to the fourth minus 6x squared plus 10. And that is g composition of f would give you x to the fourth minus 6x squared plus 10. Now, what's the domain of this function? Well, it's another fourth degree polynomial, so the domain's going to be the entire set of real numbers. So you got an entirely different function from f composition g when you switch the order around. Thankfully the domains were the same, but an entirely different fourth degree function. But the domain is negative infinity to infinity. And I have about 2 more here. Alright, we only have one function, but you're going to see this. F of x equals 2x to the 1/5. F of x equals 2x to the 1/5, so get a load of this. We're going to take f composition f. So f composition f, you can actually take a composition of the same function on the same function. How does that work, you might ask? Well, that's going to simply be f of x. Which means that whole 2x to the 1/5, you're going to put that into 2 times, put in that 2x to the 1/5 for x, so that'd be 2 times 2x to the 1/5 raised to the 1/5. That looks like quite a mess, doesn't it? Well, what you end up with is 2 times the quantity of 2 to the 1/5, and then x to the 1/5 to the 1/5, that would end up being x to the 1/25. Alright, now here's where it gets interesting. What is 2 times 2 to the 1/5? Isn't this the same as 2 to the first? Which means you're going to add the exponents. 1 plus 1/5 is actually going to be 2 to the 6/5 times x to the 1/25th, which would end up giving you literally 2 times the 5th root of 2 times the 25th root of x. You can write this in either form, but it looks like quite a doozy, doesn't it? So you end up with 2 times the 5th root of 2 times the 25th root of x. But what would be the domain of this? Well, you have an odd root of x, and as we know, you can have odd roots of negative numbers in the real number system. So there's no values of x this isn't defined for. So the domain is going to be the entire set of real numbers, from negative infinity to positive infinity. The entire set of real numbers. That one was quite a doozy, wasn't it? I got just one more. Let's see what the last one looks like. How hideous that is. Well, let's just change the notation a bit here. F of x, g of x, it's all the same. G of x equals 9x minus 2. This shouldn't be too bad at all, actually. G of x equals 9x minus 2. They want us to take G composition G. Looks like GOG. G composition G. So that is literally G of G of x. So you're going to put that whole 9x minus 2 into the x and the 9x minus 2. So this would be 9 times the quantity of 9x minus 2, where you see that x, then minus 2. Alright, well this would end up giving you, do the distributive property, 81x minus 18 minus 2, which would end up giving you 81x minus 20. So that's G composition G would give you 81x minus 20. And now what's the domain? It's a simple linear function, so it's the set of all real numbers. There's nothing that this value couldn't be that wouldn't work. So this is the set of all real numbers for the domain. Alright, so that's it for this lesson. Next lesson we are going to talk about one-to-one functions and what those are, because that's going to prepare us to deal with inverse functions. So I hope everyone has a great night. Take care.